So for length is equal to 4, right, which is our final solution. We've already seen that there are would be n minus 1 ways. So there are 3 ways possible as we have put it here. Now let's calculate the minimum cost of operations for all these 3 options, and which one out of these 3 would be the minimum. That would be our final solution. Okay. So, but as we have also already seen that this formula, whether we can reuse and whether we can formalize that how to again use the subproblem solution that we have already found. So let's try it out. So for the first case, we already know the solution of 1, 2, and 3, right, which is 48. So it would be 48 plus. Now let's see whether we can use this formula, right? I mean, as we have seen here in our previous case for length equal to 3. So, right, we start with I is equal to 0, k is equal to 0. I mean, using this formula, I is equal to 0, k is equal to 0, and j is equal to 3. 3 is the last fourth matrix. And we have to move from k is equal to 0 to k 2, right? Because k should be less than j. So for this scenario, this is the same as this. We have got k here, as k and I and k are both at 0, which is the 0th matrix, and the remaining is our the left the right side of all those matrices left. So it's 48 plus 1.2. We already get 48 plus, and now the row of, so it should be row of I that is 0 is 1 multiplied by column of k. Column of k is 0, so column of k is 2 multiplied by, for j, column of j is equal to 3. 3 is here and the column is 3. So is this formula. So 3 to the 6, 6 plus 48 is 54. Now we have to check for another 3, and then we have to choose the minimum out of it. Now here in this scenario, for this, we move our k to 1 and j is equal to 3. So again, for first of all 0 and 1, we have already seen the formula. 0 and 1 we have already solved it. It is 6 plus, again 2 for 2 and by 3 we already got 36, right? And then plus. Now again, because now we have got k is equal to 1, so again using this formula, we put it here. Row of I is still 0. So for row of I is still 0, and the row of I is 1. Similarly, column of k is 1, which is this, and column of it is 3, multiplied by column of j. Column of j is again 3, and the 4th matrix here. Okay. So this comes up with 36 plus 6, 3 3 is 9. So 6 plus 36 is 42. 42 plus 9 is 51. Okay, so 51 is better than 54. So at least, I mean, this solution is better than the previous one. Now let's look for the last option. So if we break down this matrix like this, and this would be our final case, because after this iteration k would be equal to 3. We don't want to go there because k should be less than j. Okay, so let's use this formula. Okay, 0 1 2, I think we have already solved it here. It's 18 plus, now again row of I, which is still 0, is 1 multiplied by column of k, which is the second matrix, so this one, and column of it is 4, and then finally column of j is our is 3, which is our last matrix, which is 3, right? And if I calculate this, 18 plus 12 is 30. Now 30 is minimum of these three. So it means that this is our final solution. We write 30 here. And this is our. So again, if we break it down, so we have to multiply 0, 1, and 2 first. And this 0, 1, 2 itself has been multiplied by this, like this, 0, 1 first, and then multiplied by 2. So we have to, the final solution is that just going back from here to here, because we are using 0, 1, and 2 here from this. So it should be, I'll just copy this, 0, 1, 2, okay. And then this covers this part. And so we have to multiply our matrix like this. Okay. So this is our final. I mean, if we multiply this this array, this number of matrix, then we have to use this form. That we have to multiply 0 and 1 first. Use the product of that to multiply it with the second matrix, and then use the product of all these three to multiply with 3, and then we'll get the minimum cost. Now again, as you mentioned that this is a solution, but again we have to one thing is still missing is that whether we can reuse whether we can formalize how to use the solutions from the previous subproblems. So here is this case, right? When we have this when we are adding 48 or 18 or 6 plus 36 like this, right? So let's see that whether we can formalize this. So this part, right, 6, we came from when we had like for this scenario, it's a best case scenario because here we are getting 2 values from previous one, so it's easier to formalize. So here we see that 0 and 1 we took. 0 is I is 0 and k is equal to 1, so it should be I k, right? dp ik represents the minimum value for 0 and 1, which we have already formalized. I am representing it as dp of ik, and plus the 36 that we got. 36 is when we have k is equal to 2 until j, right? So it would be dp of k plus 1, right? And j plus, for this formula, 1 multiplied by 3 multiplied by 3, we have already formalized it before here. So I'll just copy this, copy like this, okay, and here I will put it. So this is our final formula, and we have to iterate from I is equal to 0 to the final j is our last index of matrix, and we iterate k starting from I until we reach less than j. So this is our formula. And one more thing is that for this whole of the cases, we have to find the minimum out of it, right? Yeah, because we have to go through all the different scenarios, and then, for example, this we have to go through all the scenarios, and we'll find the minimum of it. So this is all the formula about this. And if I and if it's the base case is our 0 when it's only like one index of area of matrix of only like one length. Okay, so this is the formula. Now we will solve exactly same thing in Java in the next video. So see you all in the next video.